Okay, so this is the derivation for the Gibbs Helmholtz equation, which essentially relates the ratio of the Gibbs free energy over temperature with temperature. So for the first step, we want to set up the expression. So because we want to relate these two, we get the partial derivative of g over t at constant pressure. At this point, we want to use the product rule right here, with the two functions being g and 1 over t. So you keep one constant, and then you differentiate the other, and then you add it with the differentiation of the other, and then the other term constant. Essentially, that will give you g multiplied is equal to g multiplied by the partial derivative of 1 over t with respect to t at constant pressure, plus 1 over t, the partial derivative of g with respect to t at constant pressure. So we set up our expression. Now we have to look at which terms we can substitute. So from here, you should be able to refer back to the exact differential of Gibbs free energy. So that would be dg is equal to vdp minus s dAt. So where dg is equal to the partial derivative of g with respect to p at constant temperature, dp plus partial g over partial t constant p, and then dt. So from here you can see that this expression is equal to negative s, and now we can substitute the negative entropy for delta dg over dt at constant p. So our formula is now g multiplied by d1 over t over dt at constant pressure plus or minus s over t. Just know that all of this is at constant pressure. Okay, so you can actually just evaluate this. Take this function with respect to t, and then you get negative 1 over t squared, right? Because t negative 1 multiply, and negative t, and then this goes down 1, negative 2, so negative 1 over t squared. So this minus that, multiplied by that, minus st. So now we are at negative g over t squared minus s over t. Now we actually want to express entropy in terms of enthalpy. So to do that, we use the standard Gibbs free energy formula, g equals h minus ts, where s, or negative s, is equal to g minus h over t. So now we can also substitute that here. And then minus, or plus, g minus h over t. Notice that we still have another t here, so it's going to be t squared. So essentially what you're left with is negative g over t squared plus g over t squared minus h over t squared. These two cancel out, and you are left with the partial derivative of g over t with respect to t at constant pressure is equal to negative h over t squared. So usually you do want to evaluate g and h over like a change or an interval. So you just do this. The partial derivative of delta g over t over the partial derivative of t with respect to t at constant pressure is equal to negative delta h over t squared. And that is the Gibbs Helmholtz formula.